Okay, today we're going to take a look at how to solve log equations, and we're also going to look at how to solve exponential equations when we don't have a common base. So when the logs have the same base, the first thing we want to do is condense anything. So if I've got more than 2 logs on one side, I want to condense it. Here, I don't. So what I'm going to do is I'm going to use the fact that if my logs have the same base, just like when exponents have the same base, I'm going to set them equal to each other. So the x equals the y. So in this case, since they both have a base of 5, we just solve the 5x plus 9 equals 6x. So if I subtract 5x from both sides, I'm going to get 9 equals x. So there's my solution to that equation. Here, there is no base, but remember that's the common log of 10. So I'm going to condense this. When I add equations, remember that I multiply. So I'm going to get log, I'm just going to, y plus 5 times 4 equals log 72. And now since they both have the same base, I can set them equal to each other. I'm just going to move the 4 out in front. And that equals 72. I like to divide first if I can. That's just me. You could distribute it if you wanted to, but 72 divided by 4 is 18, so I get y plus 5 equals 18. And if I subtract 5, y equals 13. Okay. Again, you could have distributed first and got 4y plus 20 equals 72. And then if you subtract 20, you get 4y equals 52. And divide by 4, y equals 13. So either way works. Okay. Now when I've got a log equal to a number, I can't set them equal to each other. So what I've got to do is I got to isolate that log. So I'm going to condense any, and then I'm going to isolate. Okay. So I'm going to add 7 to both sides here. So I get log 3 of 4x plus 8 equals 4. And then I'm going to use that change. I'm going to write that as an exponential form. So remember, log with the base of a equal to the x is the same as b to the x equals a. So you switch. So the base here is 3. So 3 to the 4th equals 4x plus 8. So now you know how to solve that. 3 to the 4th is 81. Okay, if I subtract 8, I get 73 equals 4x. And if I divide by 4, x equals 73/4. Just double checking because that just seems off, but it's not. All right. So now in this case, I've got to do some condensing. So remember that when we subtract, that's division. So I've got log with the base of 10 is x. This is an exponent, so that becomes x squared over 4 equals 2. And so now I can rewrite that as an exponential. Again, that base is 10 if there isn't one there. So 10 squared equals x squared over 4. So I'm going to get 100 equals x squared divided by 4. And then 400 equals x squared. So x equals positive or negative square root of 400, or positive or negative 20. Now you want to check this for extraneous roots just by putting it in 2 log 20 minus log 4 and 2 log of negative 20 minus log of 4. And since this is base 10, you can just plug it into your calculator, and 2 log of 20 minus log of 4, if you just plug it into your calculator, gives me 2, so that checks. And if I put 2 log of negative 20 minus 4, log 4, sorry, it gives me an imaginary solution. So that negative 20 doesn't work, and my solution is just 20. So you should get into the habit of checking for extraneous roots. Okay. Now sometimes we don't have, I should say, a common base, not a common exponent. So what can we do? What I can do is I can go ahead and I can isolate things, okay, and get this all by itself. So the first thing I'm going to do is I'm going to add 3 to both sides. So I get 8 times 11 to the 7k equal to 216. Then I'm going to divide by 8 because you can't multiply that 8 times 11 because they've got different bases. You can't do that. So you want to divide. 216 divided by 8 is 27. So I get 11 to the 7k equals 27. Well, I know that 27 is 3 cubed, but 11 is prime, so I can't do anything with that. But what I can do is I can go back to my log and rewrite that as a log. So b to the x equals a. So I'm going to go the other way. So this is my base. So I've got log 11 and 27 equals 7k. So what I can do then is use the change of base to get an estimation of what this is. So log 27 divided by log 11 gives me approximately, so I'm going to come over here, 1 37/100ths, and then I can divide that by 7, and I'm going to get k to be approximately 20 hundredths, or 2/10 when I round to the nearest hundredth. All right, so today we learned how to solve log equations and then how to solve exponentials with logs. Have a math-tastic day.